Greg Butler here, Research and Development Manager for the South Australian No-Till Farmers Association. Since about 2008 we've been looking at biochar in broadacre field application, and in combination with diammonium phosphate, low rates of banding biochar at 35 kilos a hectare have given us some pretty good results. In this graph we see 5 treatments measuring the yield response. The first treatment is a nil treatment without any diammonium phosphate or any biochar. The 2 orange bars indicate firstly 50 kilos per hectare of diammonium phosphate and 100 kilos per hectare of diammonium phosphate. So we see a yield response from nil to 50 to 100. A very competitive treatment in that trial is in fact the first blue bar, which is 50 kilos of diammonium phosphate plus only 35 kilos of biochar. In addition to our in-crop field work, some years ago we looked at a biochar filter for an acid sulphate drain. Now the drain was running at pH of 2.1, and what our task was to raise that pH. And we were successful in doing that. We raised it from 2.1 up to about 6.5, so that was a really good outcome. However, in that drainage water there was also a significant quantity of nitrate. There was about 580 parts per million of nitrate. And after the biochar filter, we found there was less than 5 parts per million of nitrate. So the char filter had done a significantly good job in removing nitrate from that water. And putting that in the context of our wider farming system, we wondered how that could be used in the leaching of nitrates from soil. Each year there's about 200 million tonnes of anhydrous ammonia manufactured for fertiliser use, and a substantial quantity of that is leached out of profiles, being a waste of money to the farmer that buys the fertiliser and also having environmental degradation effects. Now, with the advent of conservation agriculture and the reduction of tillage and the increased crop residue retention on the soil surface, we're seeing a significant increase in the infiltration rate of moisture. In this next graphic we have 2 graphs. One is the summed graph of soil moisture in a system where the stubble has been removed, and the other one is the sum graph in a system where the stubble has been retained. We can see that the infiltration rate in the stubble retained system is significantly higher than the infiltration rate of moisture in the stubble removed system. That infiltration rate of moisture is very important, and in dry springs that deep water is helping to fill crops that otherwise 15 years ago would have ended up as screenings or basically as a dead crop. So this infiltration rate of water that we're seeing from the adoption of conservation farming practices is extremely important, has enormous economic value, but at the same time, one thing we've got to be wary of is if we're increasing our infiltration rate of moisture into the soil, are we in fact also increasing our risk of nitrate leaching? In this next graphic we have 2 graphs. Sitting on top is a graph of electronic conductivity in the soil at 10 centimetres and at 70 centimetres in black and brown respectively. A graph sitting below that is the separate layer graph showing soil moisture at 10, 20, 30, 50, 70 and 100 centimetres. As we see the soil moisture penetrate deeper and deeper into the soil, when the soil moisture wetting front passes through 70 centimetres, in the conductivity graph, we see a significant increase in electronic conductivity, showing us the leaching of nutrients out of the soil profile. In 2013, in the European Journal of Soil Science, there was a paper published looking at the effect of pine wood biochar on nitrate leaching from sandy soils. What that showed was that relative to a control, 0.5 of 1% of char reduced nitrate leaching by 26%. 2.5% biochar reduced nitrate leaching by 42%, and 10% biochar, which is a lot of char, reduced nitrate leaching by 96%. So in conjunction with the Adelaide Mount Lofty Natural Resources Management Board, SANFL wanted to assess what would happen to some of our local soils and nitrate leaching at low rates of char. So we set up a pot trial with 35 kilos per hectare of biochar equivalents. What the data from the pot trial showed us was that the addition of a nitrogen-based fertiliser, in this case UAN, did increase the amount of nitrate that was leached from the pots relative to the nil treatment. What we also see is that there's relatively more nitrate leached depending on the type of plant or no plant that was in the pots. Where there was no plant in the pots, we see the greatest amount of nitrate leaching because there's no root system to intercept either the water or the nitrogen. In the legume system, which has a relatively low root mass and fixes some of its own nitrogen, we see a reduction relative to the no plant, but more nitrate leaching than the wheat. The wheat has the highest root mass, as well as the greatest demand for soil moisture and also for nitrogen within the trial. And so we see the least amount of nitrate leaching from the addition of UAN through that treatment. What we can also see in the data is that relative to the nitrogen fertiliser applied by itself, which had the highest amount of nitrate leaching, the addition of biochar and nitrogen fertiliser together had a reduced rate of nitrate leaching across all treatments. In the pot trial, we also had treatments with pasture so that we could look at dry matter production across the nil treatment, the biochar only treatment, the nitrogen only treatment, and the combination of biochar with nitrogen fertiliser treatment. What we have found effectively was that the nil treatment had the lowest yield on trend, and that the UAN and the biochar treatments as individual treatments were very, very similar in their yield, and that the best yielding treatment in terms of biomass production was the nitrogen fertiliser and the biochar in combination. In conclusion, I'd like to thank the Adelaide Mount Lofty NRM Board for supporting Sanford's work into biochar and the role it may present in reducing nitrate leaching from cropping soils. The data from the pot trial, in combination with the peer-reviewed literature, suggests that biochar, even at relatively low rates of 35 kilos a hectare, may have a beneficial effect in reducing nitrate leaching from cropping systems. In turn, increasing nitrogen use efficiency and reducing the cost of production for the farmer. At the same time, nitrate leaching is responsible for soil acidification, and by reducing nitrate leaching, we can slow the rate of soil acidification and also reduce other off-target damage from nitrate leaching. Thank you.